Okay, today, boys and girls, we're going to be multiplying fractions. So if you would, go ahead and let's write down multiplying fractions. We're going to be using models today to multiply fractions. Our model, of course, is going to be a candy bar because that's one of my favorite things to draw. So let's everybody draw a candy bar. In looking at this candy bar, since we're multiplying fractions, we're going to be multiplying two fractions. One of the fractions is going to be written over to the left, and the other one will be written on top. So I'm thinking of two fractions that I want to multiply. One of them is 1/4, and the other one is going to be 1/3. When we say we're multiplying fractions, let's use our bold dot in the middle to say that we're multiplying. So I've set up an equation. So we need to cut our candy bar into fourths. I'm going to start from the top up here and label this 1/4. So when I cut, I'm going to cut coming down from the top to the bottom 4 equal pieces. And I want to shade in one of those pieces. Now notice I'm striping my candy bar piece that I want to shade in instead of coloring him all the way in. Now I'm going to switch colors to show you that 1/3 is going to be drawn from this side, from the left to the right. We're going to go across the candy bar and we're going to cut into thirds. So I'm going to cut all the way across into thirds. Now if you're not sure if you cut into thirds, you can count over to the side, 1, 2, 3 pieces. And I want to actually shade one of these 3 pieces. So I'm going to shade all the way across, just like I cut my candy bar. So now what we are looking at is 1/3 being shaded in green and 1/4 being shaded in blue. You should also notice now that I have a piece of the candy bar that has been shaded both green and blue. So let's find him and circle him and identify him as being double shaded. When I'm working this and thinking about multiplying, my double shaded is the representation of my answer. So I have one piece that is double shaded. Out of how many total pieces has my candy bar been cut up into? I have a total of, if I count them, 12 pieces. So my answer over here is 1/12. But if you look at it mathematically, what can I do to mathematically get the same answer with my numerator and my denominator? If I multiply my top times top, would I get 1? If I multiply the bottom times bottom, would I get 12? So we're going to create a rule and see if it works. That sounds something like this. Top times top, bottom times bottom. Is there anything else that we might need to think about to get a final answer? Well, the only thing that I might want to think about is sometimes I might need to reduce. So here we're going to try another problem and see if these same rules apply. So let's go ahead and try and draw a new candy bar. And this time, our problem is going to be 1/3 of 3/4. Do you notice that I did anything different in this problem than the other problem? Oh, of course, I see that word of. I wonder what of means. Well, if we want part of a part, here's that word of. It means to multiply. So let's shade in and cut our pieces up into thirds. And let's label this 1/3. And yes, let's shade 1/3. Now I need to cut up into fourths. And how many pieces will I shade? 3. Because I have 3/4. And let's look. I'm looking for double shaded to guide me with my answer. So I'm looking for anything that is double shaded. 1, 2, 3 pieces are double shaded. Out of how many all together? And that would be 12. Oh, but wait a minute. I think I can reduce. So if I reduce, I will get 1/4 because I divided by 3 on the top and 3 on the bottom. And 1/4 will be a final answer, which you should also be able to tell me that that is 0.25 as a decimal. So let's go back up to our problem up here. If I stick to those rules of top times top, bottom times bottom, will I come up with the same answer? So let's give that a try. Top times top, 3. Bottom times bottom, 12. And can I reduce? Yes. Did we come up with the same answer as our picture? Absolutely. Good job. Now you're going to give it a try.